Good morning. Come to 25th question. 4 point charges plus 5q, plus 5q, minus 5q and minus 5q are placed at corners A, B, C and D of a rectangle as shown in the figure. If P is midpoint of side CD, the work done in carrying a charge Q from center O to P will be. Question number 25. The given figure A, B, C and D. Here at A they placed plus 5q, at D they placed minus 5q and at B plus 5q and at C minus 5q, and this is center O, side length is 3L. Clear? And this side they mention this side length is 4L. This is the midpoint of AB. So this will be, sorry sir, this is not exactly 4L. According to figure, this is 8L. This distance they mentioned as 4L and remaining also 4L. This point is P. Okay, they are asking if P is the midpoint of side CD, okay, the work done in carrying a charge Q from center O to P. Here they are asking work done to move a charge Q from O to P. Clear? So work done, we will write V into Q. Okay, here this expression we can write delta V into Q. Clear? So difference in potential into charge. So this we can write V2 minus V1 or Vp minus Vo into Q. Vo means potential at center, Vp potential at P. Now first calculate potential at center, Vo. Clear? Potential general formula V is equal to 1 by 4 pi epsilon naught Q by R. Now total 4 charges are there. 4 charges contributes potential at center. Potential is a scalar quantity, so you add all potentials. So plus 5q we have a plus potential, minus 5q we have a minus potential, plus 5q we have a positive potential, minus 5q we have a negative potential. So total see V plus V minus plus V plus V minus. See, magnitudes are same and distance of each charge to the center remains same. So 2 are positive, 2 are negative, total potential is 0. Clear? Now we need to calculate potential at P due to all 4 charges. Now potential at P. Clear? Now due to this charge, due to 5q placed at A, 1 by 4 pi epsilon naught 5q by the distance of A to P is 4L. 4L. Next, you take B. This is also positive charge. Distance between P to B is 4L. So this is plus 1 by 4 pi epsilon naught 5q by 4L. Next, negative charge. So negative is there, potential is minus, so I can write directly minus 1 by 4 pi epsilon naught phi q by distance of phi q to p. We need to take this distance. Clear? Understand? This is 4L, this is 5L. Obviously this length is, this is 4L, this is 3L. This will be 5. Under root of 4 square, 4L square plus 3L square, we will get 5L. So 5L. Next, due to this charge, potential due to minus Q at P. Again minus is there, so I am writing minus 1 by 4 pi epsilon naught phi q by, again this distance will be same. This is 4L, this is 3L, and this will be 5L. So 5L. Clear? Now 1 by 4 pi epsilon naught q by L, you take it common. 5 by 4 plus 5 by 4. Here cancel minus 1, here this cancel minus 1. So this is 1 by 4 pi epsilon naught q by L. This 10 by 4 minus 2. And this is 1 by 4 pi epsilon naught 10 minus 8 by 4. This is equal to 1 by 4 pi epsilon naught 10 minus 8, 2 by 4. 2 ones. Q by L we are missing, so Q by L, Q by L, 2 by 4. Ones, 2. So we have 1 by, according to answer we will make it this. Clear? 1 by 4 pi epsilon naught q by 2L. Now this is potential at P. Now work done is equal to 1 by 4 pi epsilon naught q by 2L into small q. But this 1 by 4 pi epsilon naught, they are asking us to take K. So K Q by 2L. Now come to for the options. Option 2 is correct. Now come to 26th question. In the electric field due to a point charge minus Q at a point charge small q is carried from O to the point P, Q, R and S lying on the same circle M around minus 2. The work done is minimum along OP, minimum along OR, minimum along OS, 0 along any path. Come to the 26th question. At the center, minus Q is placed and they given some points. Yes, Q, O, P and R. They are asking work done minimum along which path OP, OR, OS, 0 along any path OP, OQ, OR and OS. Already I mentioned work done formula. This if you take, so work done is equal to difference in potential V final minus V initial into Q or delta V. Now if you take a distance, our radius is R. So potential of this charge will be 1 by 4 pi epsilon naught Q by R. Minor charge is this, you can write minus. Anywhere on this circumference, radius remains same. Radius remains same, magnitude remains same, then potential each and every point remains same. Clear? According to this relation. So potential remains same. What would be the difference? Any 2 points is 0. So difference in potentials. Any 2 points is 0, then work done is 0. So this surface we call it as an equipotential surface. Clear? Work done on equipotential surface is 0. Reason is at every point potential is same, magnitude of potential is same. If we take the difference, we will get 0. Then work done is 0. Now 27th question, 2 point charges A and B have charge plus Q and minus Q of mass M and 2m respectively as shown. Both the charges are released from the rest when they are at distance 2m. The speed of A when separation between them reduced to 50%. Consider only electric force. Now, according to the question, this is minus Q and 2m. This is B. Initial separation between them is 2m. Then they are asking the speed of A when separation between reduced to half. Reduced between half means separation will become L. This is A and this is B. Let us say this is VB and this is VA. VA they are asking. Clear? Now we how to follow law of conservation of energy. Initially, which energy is there? They are released. So initial velocity is 0 and here also initial velocity A is 0, B is 0. Both do not have any kinetic energy. They have only potential energy. So that potential energy is what? Electrostatic potential energy. That is 1 by 4 pi epsilon naught. Because why I have taken minus? Already minus charge is there. So charge will be remain same. So this is Q square by what is the separation between them? 2L is equal to. Here both will have kinetic energy. So this I can write half m VA square plus half m VB square minus, again they possess potential energy. This is minus charge and this is plus charge. So this we can write 1 by 4 pi epsilon naught Q square by, what is the separation between them? L. So they are asking VA. In this equation, we need to eliminate VB. That how do we get VB? This we will get by using law of conservation of linear momentum. Initial momentum of each particle is 0. So P initial is equal to P final. Initial their momentum is 0 because they released. So initial velocity is 0. Initial momentum is 0. Now this 0 is equal to this velocity. If we take it VA, this mass may given m, this mass given 2m. Then this we can write m VA plus. If you take it this positive, this will be negative 2m VB. To get VA, what we need to eliminate? VB. So make it this 2m VB subject to this m VA. Then what m cancel? VB is equal to what? VA by 2. This VB value substitute in this expression. Then this comes to this side, it will become plus minus 1 by 4 pi epsilon naught Q square by 2L plus 1 by 4 pi epsilon naught Q square by L is equal to half m VA square plus of m. Here m is mass of second body is what? 2 m. Vv square. What is Vv? Va by 2 whole square. Here 1 by 4 pi epsilon naught q square by L is common. This is 1 minus 1 by 2. This is completely 1. We have 2. So 1 by 2 minus 1 by 2. Clear? Now half m Va square plus half 2m Va square by 4. Clear? And now this 1 by 4 pi epsilon naught q square by 2m, because 1 minus 1 by 2, 1 by 2 is equal to, now we need to simplify this. What do we take common? Half m v square. If we take it common, what do we get? 1 plus, clear, m v square by half m v square common. We have a 2 by 4. 2 by 4 means 1 by 4. So 1 by 4 pi epsilon naught q square by 2l half m Va square. This is 3 by 2. Now rearrange, we will get the answer. They are asking Va, and this goes to 4 in terms of 8 is there. Now we will make it simple. Now this is 2 to 4 comes this side, 4 pi epsilon naught q square by 2l is equal to 3m Va square. Now Va square I am making subject to, Va square is equal to 4q square by 4 pi epsilon naught 2l into 3m, which 6m is there. So 4 cancel. Then Va is equal to under root of q square by 2 into 3, 6 pi epsilon naught L m. So option 2 is correct. Option 2 correct. Clear? Now come to 28 question. A point charge plus q is fixed at O. Another charge particle having charge minus q and mass m, moving with a constant speed in a circular orbit of radius r and around O. The work required to increase the radius of revolution of minus q from r to small r to capital R. 28 plus q is placed at the center. Let us take circular orbit of radius small r. At the center we have a plus q, and here minus q charge is revolving. Clear? Now they are asking work done to increase radius up to capital R. Again it revolves around this earth. So what do we do? Work done is equal to what? Changing energies. So here find out total energy means kinetic energy plus potential energy. Clear? Now first we will try to find out total energy. So kinetic energy, potential energy first write down. Potential energy U is equal to 1 by 4 pi epsilon naught. This we have because this is negative charge. So q by small r. Now we need to find out kinetic energy. Kinetic energy formula of m v square. So when this charge particle revolves in a circular path, it experiences centripetal force that is provided by centripetal force. It experiences centripetal force that is provided by electrostatic force. So 1 by 4 pi epsilon naught capital Q small q by r square is equal to m v square by r. Clear? M v square by r is the centripetal force. This is because of this force. Minus sign because attractive. I am not writing. Minus indicates in the force. Minus indicates attractive force. So 1 r will be cancelled. What we require? Half mv square. We have only mv square. So multiply both sides half. Then this is 1 by 8 pi epsilon naught q by r is equal to half m v square. Now this is nothing but kinetic energy. Then total energy is what? E is equal to k plus u. What is k? 1 by 8 pi epsilon naught q by r minus 1 by 4 pi epsilon naught q by r. Clear? So 1 by 4 pi epsilon naught q by r, if you take it common, 1 by 2 minus 1. Then we will have a 1 by 2 minus 1, we will have minus of minus 1 by 8 pi epsilon naught q by r. Clear? This is the energy, initial energy when the charge is at orbit r, the energy is minus 8 pi epsilon naught q by r. Now it moves to another radius r, so we increase the radius, then E final. Then how do we write? 1 by 4 pi epsilon, this energy will be minus 8 pi epsilon naught q by capital R. Work done is equal to what? Change in energy. E final minus E initial. In E final minus E initial. This is initial, this is final. 1 by 4 pi epsilon naught q is common, 8 epsilon. 8 epsilon naught is common. Clear? So this is minus 1 by r minus of minus 1 by small r. Then this will be q by 8 epsilon naught minus of minus plus 1 by r minus 1 by r. So option is 3.